Alright folks, we're continuing with our Stoichiometry worksheet 2. The problem was it was just getting too long, so decided we'd break it up. Alright, we're reacting copper sulfate, CuSO4, copper 2 sulfate. We're reacting it with barium nitrate, NO3. Barium's +2, nitrate is -1, so it's BaNO3 and it is producing barium sulfate, BaSO4, and copper nitrate, CuNO3, and it's copper 2, so it's NO3 Right, and it says we're starting with 43.5 grams of copper sulfate. That's this one. So we have 43.5 grams of copper sulfate. We're saying how many grams of precipitate are formed? Well, if you go back and look at your solubility tables, or if you happen to remember, anything with nitrate is aqueous, which means the barium sulfate is the one that's the solid, and if you look it up, you'll find out that barium sulfate is in fact solid. So we're trying to figure out how many grams of barium sulfate we have. Okay, so what we have to do first is figure out how much copper sulfate weighs. And copper 2 sulfate, if you go out and look at your periodic table, do the math, you get 159.608. And if I look at barium sulfate, I can figure that one out, and that's 233.39, and that's grams per mole in both cases. Okay, so let's go ahead and do our problem. We have 43.5 grams of copper sulfate, copper 2 sulfate. And we are going to get rid of grams of copper 2 sulfate, and we always go to moles. Now we have to go to moles of our starting substance, which is CuSO4, and then we go from moles of copper sulfate. We're going to moles of our target, and our target is barium sulfate, which is BaSO4, and then we go from moles of barium sulfate to grams of barium sulfate. Alright, before we go any further, let me mention that the equation up above us is balanced. So that was something we had to make sure that we did. I forgot to mention it, but I had already balanced it, so I knew that it was balanced. Alright, so 1 mole of copper sulfate we figured out weighed 159.608 grams. And 1 mole of copper sulfate gives us 1 mole of barium sulfate. We can see that up here because our coefficients are both implied to be 1. And 1 mole of barium sulfate gives us 233.39 grams in 1 mole. So if I proceed to do all the math there, I am going to come up with 63.6 grams of barium sulfate. Again, you have 3 digits of precision in your problem. You have 3 digits of precision in your answer. Okay, how many liters of hydrogen gas are formed at SDP when we have calcium, 13.5 grams of calcium reacted with sulfuric acid? We're trying to figure out liters of hydrogen gas. So we have calcium reacting with sulfuric acid, which is H2SO4, and we are producing hydrogen gas, that's H2, and we're producing calcium sulfate, CaSO4. And if I look at that, everything looks balanced to me. So we have 1s everywhere, so that's helpful. Liters of hydrogen gas, we always work with the number 22.4. In calcium, we have to look at how much that weighs, and that's 40.08 grams per mole. So I can now start with 13.5 grams of this, and I'm trying to go to how many liters of that I have. Well, notice our coefficients are both 1. Alright, so let's go ahead and do the math. 13.5 grams of calcium, and I have to get rid of, there's a decimal point there, and get rid of grams of calcium and go to moles of calcium. But I don't want moles of calcium, I want moles of hydrogen gas. But I really don't want moles of hydrogen gas either. I really want liters of hydrogen gas. Well, 1 mole of calcium weighs 40.08 because we looked that up. And we see that 1 mole of calcium gives us 1 mole of H2, and 1 mole of H2 is 22.4 liters. So if I take the 13.5, divide by 40.08, and multiply by 22.4, I in fact get 7.54 liters of H2 gas. Alright, calculate the mass of silver needed to react with chlorine. So that means silver is reacting with chlorine, Ag plus Cl2, to produce silver chloride. Plus 1, minus 1, so that means they cancel. That means that I need 2 of these and 2 of those to make the equation cancel, to make the equation balance, excuse me. I'm starting with 84 grams of silver chloride. Now what do I want to do? Well, I want to get from grams of silver chloride, which is 84 grams of this, and I'm trying to figure out the mass of silver. So how much silver do I need? What's my mass of silver in grams? Right? So to do this, I have to figure out how much silver weighs, and I'm going to have to figure out how much silver chloride weighs. Well, silver chloride, if I look it up, weighs 143.32 grams. And if I look up silver, just silver, straight silver is 107.87 grams per mole. Alright, so I'm going from grams of AgCl to moles of AgCl. And I'm going from moles of AgCl to moles of Ag, because that's what I'm asking about, is moles of silver. That's my target. And I can get rid of moles of silver, and I can go to grams of silver, because I know how much silver weighs. So let's start right there. 1 mole of silver weighs 107.87. And 1 mole of silver chloride weighs 143.32 grams in a mole. And my relationship between silver chloride's 2, and silver is 2, so it's a 2 to 2 relationship, which is going to cancel each other out. So I've got 84 divided by 143 times 2 divided by 2 times 107.87, and that's going to give me 63 grams of silver. You say, wait a minute, that's not what my calculator gave me. Well, that's true, but notice you only have 2 sig figs in your problem, so you can only have 2 in your answer. Okay, number 9. We're producing some hydrogen gas. Specifically, we're producing 7.5 liters of hydrogen gas, and it's being replaced from a single replacement reaction of zinc with nitric acid, and calculate the mass of zinc. Alright, so let's see what we have. We have zinc, and we have nitric acid, which is HNO3, hydrogen nitrate, and it is producing zinc nitrate. Good, Skip. Let's try that again. Zinc nitrate, and there have to be 2 of those, plus hydrogen gas. Why 2? Because zinc is plus 2 and nitrate's minus 1. Okay, so let's see, to balance this I have to put a 2 in front of my nitric acid. Okay, so I have 7.5 liters of hydrogen gas. So I have 7.5 liters of hydrogen gas. And calculate the mass of zinc. Zinc. Calculate the mass of zinc. Alright, so let's see, how much does zinc weigh? Let's look on the periodic table. Zinc weighs 65.39 grams per mole. Right. So let's see, let's go through my math here. I'm starting with 7.5 liters of H2 gas. And I can get rid of liters of H2 gas and go to moles of H2 gas. And then I can go from moles of H2 gas. Now I'm making my switch over to the other thing, so I can go to moles of zinc. And then from moles of zinc, I can go to grams of zinc. Right. So every mole of hydrogen gas is 22.4 liters at STP. My relationship of hydrogen gas, which is 1 to zinc, is 1. And 1 mole of zinc weighs 65.39 grams. So if I sit down and I do all my math, taking the 7.5, dividing by 22.4, multiplying by 65.39, I get 22 grams of zinc. Now notice it's only 2 sig figs here because you've only got 2 sig figs. up here in your problem. So it's going to be 22 grams of zinc. All right, only a couple left. Here's number 10. How many molecules of chlorine are needed to react with iron to form iron 3 oxide? So those are the two things I care about, but I still need to go and create a balanced chemical reaction. So I need to take iron and I have to react it with chlorine gas, which is Cl2. It's a Brinkel-Hoff element, and it is producing iron 3 chloride, which is FeCl3. You need to react with that to form. So that's it. This is simply a combination reaction. Okay, well I've got a 3 and a 2 for chlorine, so I put a 2 there and a 3 there, which means I need 2 irons. Okay, so there's my balanced chemical reaction. And I start with 5.6 grams of iron. Ooh, so I'm going to have to look up iron and see how much it weighs. Well, iron, if I look it up on the periodic table, iron weighs 55.847 grams per mole. Now, I'm looking for molecules of chlorine. Don't need to look that up. So that's always the same thing. That's always 6.02 times 10 to the 23rd. So let's see, I'm getting rid of grams of Fe, and I'm going to moles of Fe. And from moles of Fe, I'm going to moles of, what am I asking? Molecules of chlorine. So I have to go to chlorine gas. And then I go from moles of chlorine gas to molecules of chlorine gas. Alright, so what numbers do we put in? Well, we know that 1 mole of iron weighs 55.847 grams. And our relationship between moles of Fe, which is 2, and moles of chlorine, which is 3, goes there. And 1 mole of chlorine gas, I have to figure out how many molecules that is. Well, that's always 6.02 times 10 to the 23rd. Alright, so I take the 5.6, divide by 55.847, it's supposed to be a 7 there, multiply by 3, divide by 2, multiply by 6.02 times 10 to the 23rd, and I get 9.1, notice only 2 sig figs, times 10 to the 22nd molecules of chlorine gas. Alright, last one. How many liters of chlorine gas are required to react with chromium? So I have chromium, and I'm reacting with chlorine gas, and I'm producing chromium 3 chloride, which is CrCl3. Well, gee, we're back to that 3 and 2 business again. This looks a lot like the last one. Right, we want liters of chlorine gas, so that's the 22.41, and we're dealing with 8.66 grams of chromium 3 chloride, so that's this guy, 8.66 grams. So I need to figure out how much that weighs by looking at the periodic table, and I can figure out that that weighs 158.355 grams. Alright, so let's go ahead and do the math here. We're starting with 8.66, and what is this? This is grams of chromium chloride, CrCl3 of chromium 3 chloride. And I want to get rid of grams of CrCl3, and I want to go to moles of CrCl3, but I don't want moles of Cl3, I want moles CrCl3, I want moles of chlorine gas. Sorry, that's Cl2, my bad. And I want to go from moles of Cl2 to, what's it asking for? It's asking for liters of Cl2. Alright, well, liters of Cl2 is real easy. They're 22.4 liters in 1 mole. And my ratio between chromium chloride, which is 2, and chlorine gas, which is 3, goes right there. And every mole of chromium 3 chloride, how much does it weigh? Well, we looked it up, and that weighs 158.355 grams per mole. Okay, so I do the math. So I take the 8.66, divide by 158.355, multiply by 3, divide by 2, multiply by 22.4. 1.84 liters of Cl2 gas. And that is my final answer. Folks, that's the last one for today. Hope that helps you. If you still have questions, come see one of us in class, and we'll be more than happy to help you. Have a great day. See you soon. Take care. Bye-bye.